Okay, so let's look at the theory behind the part 2 of the experiment. So please watch this video before you complete in the lab manual so you won't get confused. All right, so this is the basic equation that's provided on the lab manual, which is time period equal to pi L over G and square root of that. L represents the length of the pendulum and G is the gravitational acceleration. Now let's do a little bit algebra here. So maybe from your middle school or maybe elementary school, you know, like how to solve these equations, right? So here, what we're going to do is we're going to change the length and measure the time period. So my independent variable will be the length of the pendulum and my dependent variable going to be the time period. So I'm going to change L and measure the time period. Here, having the square root is making us driving crazy, right? So we need to get rid of this square root. So what we're going to do is we're going to take the square of the equation on both sides. So if I do that, I get t to the power 2, which is t squared. And then I have 4, which is square of 2, and pi squared. And I can get rid of this one by taking the square of that. So square root is gone away. So I have L over G. Now I like to rearrange this equation a little bit by moving G off from L because L going to be my independent variable. So here I have t to the power 2, 4 pi squared over G times L. Now here, as I mentioned, L going to be my independent variable and t to the power 2 going to be my dependent variable, sorry. So here, I'm going to represent the t squared in y-axis of the graph and L is on the x-axis of the graph. So basically, I'm going to plot a graph and t squared will be represented on the y-axis and length will be the x-axis. Now, when you are using the data and when you're plotting the graph, you need to use Excel. So if you don't have Excel with you, you may use Google Spreadsheets and then you can save it as a Excel file or into a Word file and attach to the assignment. I mean, when you're submitting the assignment, you may attach it as a separate graph page. Well, so let's move on to the theory again. So I have t squared versus length graph. So as you see here, it's a linearly dependent graph, right? So t squared is proportional to L. So here, this quantity over here is a constant. It's 4 pi squared over G. So the shape of the graph should be a straight line. So using the data, add a thread line. So you're putting a trend line and make sure to insert the equation. So when you insert the equation, you will see a equation looks like this. So y equal a number times x plus another number. So here m is the slope of the graph. I think you already know it. But what is that m represent? So here the slope of the graph, right? So the slope of the graph is equal to 4 pi squared over G. So look at this one. We plot t squared on the y-axis, L on the x-axis. So the remaining piece represent the slope. So here 4 pi squared over G is the slope of the graph. Now let's rewrite that equation. So slope is 4 pi squared over G. And we need to solve the G experimentally. That's the goal of the lab, right? So G experiment is going to be I do cross multiplications here. So I get G experiment is equal to 4 pi squared over slope. So basically, all the labs that you did earlier using Excel, the slope is equal to your unknown value. But here we are going a little bit in advanced method. So the slope is not directly equal to your unknown value, but you need to do one more mathematical step. So G experiment is 4 pi squared over slope. So once you plot the graph, you can get the slope from the graph and then you're going to plug it over here in this equation and you can calculate the gravitational acceleration experimentally. So in table 2, G experiment going to be whatever the number that you produce from your data using this equation. And then G theory is 9.8 meters per second squared and you can calculate the percent error by calculating the experimental G minus the theoretical G divided by the theoretical G value and take the absolute value, time it by 100. And that gives you the percent error in your measurements. Actually, it's going to be my measurements, so there will be some error as well. All right, so when you answer in question number 6, please read it and think about the given time. So it's telling you, like, if you want the pendulum to take 2 seconds to swing from one side to the other. So think about that. So is that the time period, or is it half of the time period? I'll leave it to you. So you may spend some time, just analyze that. All right, so I'll see you next week. Stay safe.